Okay, the next type of example is factoring again, but by what we call grouping. It's the grouping method, so you want to label that somewhere, the grouping method. Now, notice that this is not a binomial, not a trinomial, but there are four terms right here. Since there are four terms, we are going to group them into twos. Okay, how do you group them into twos? Well, you could take the first two and the second two, as long as they got something in common. Like, look at the first two, x cubed and x squared. They got something in common. Look at the second group, 16 and 48. They got something in common. So step one is you're going to take these two and find the GCF, which is x squared. You're just going to factor it out of these two. So that becomes x squared times x, minus x squared times 3. Out of the second part here, 16 and 48, you're going to pull out a 16, but since they're just minus 16, it makes it a little tricky, so you're going to pull out a minus 16 instead of just 16. Okay, times x, and be careful, minus 3. Alright, now, I pulled out GCF out of the first two, pulled out GCF out of the second two, and watch what happened. These two things inside parentheses are the same thing. So basically right now, that is your GCF. Like, this is common in both terms here. So if this is all one term, that's common. If that's all one term, that's common. So what we're going to do is we're going to pull that out. We're going to pull x minus 3 out. And all we're going to do is write whatever's left over. That's left over, and that's left over. X squared minus 16. So what you just did is factored by grouping, but if you paid close attention, we're actually not done yet. Many times you'll be done, but not this time. So step one, pull out GCF out of these two, pull out GCF out of these two. There they are. Step two, pull out this GCF. This is common in both, so we pulled it out to here. And then we wrote down whatever was left over inside the parentheses here. But be careful, sometimes these will go again. So x minus 3 cannot factor again, but this is a difference of squares. X minus 4, x plus 4. We completely factored this up here. If you FOILed, or if you multiply these three things together, you would get what you see above. Okay, example 4. We're going to factor polynomials again, but there's a different type of form up here, quadratic form. We'll get to that. Let's look at this right here. If I told you to factor this right here, step 1, look for GCF, which 16 and 81, there's not a GCF. You notice it's a difference. The next thing you think, is it a difference of squares? Is it a difference of cubes now? Now you know that. Well, I know it's not a cube. I mean, 4 power. The fourth power can't be a cube, so we're okay on cube. But is it a square? So what you have to look for, is this a difference of two squares? Well, I know 81 is a square. That's 9 squared. 16 is a square. That's 4 squared. And x to the fourth is a square. X squared squared. So all of this in the parenthesis right here, squared, gives me 16x to the fourth. So 16x to the fourth, this guy right here, is a square. It is 4x squared squared. Why did I write it like this? So that I know my A and my B. This is a difference of squares right here. All you're going to do now is use your A minus B, A plus B. So here we go. A is all of this right here, A squared, so A is 4x squared minus B, which is just 9. And then you got 4x squared plus 9. You look at these two again and say, do those factor? Well, this is the sum. Well, the only thing that can factor so far is the sum of cubes. 4 isn't a cube, x, none of these are cubes, so that's okay. So over here you have minus, so you're going to ask yourself, is this a difference of squares or difference of cubes? Well, I know it's not cubes, but look at this. 9 is a square, 4 is a square, x squared is a square. So this becomes 2x minus 3, 2x plus 3. If you factor this as a difference of squares, here it is. But then you still got 4x squared plus 9. And there you have it. Here is your final answer, all factored out.